What we're proposing is radical health. And the reason I say that is medicine today is largely a failed entity for a number of reasons. One, the quality of health care in the top 20 nations has the U.S. almost at the bottom of those 20 nations, in spite of the fact we spend 3 to 5 times as much as the next spender in health care. And this means that we're paying a lot of money and we're not getting a lot of quality. But the second aspect of the failing is the entire system lives off disease. The only place you really make money in medicine is if the patient's sick. They don't really care that much if they're well or if you can prevent it. My own feeling is within 5 years, we'll start to see many of the consequences of a data-driven health. And I would guess in 10 to 15 years, we'll see the real revolution.
Welcome to the Performance Initiative podcast.
Our goal is to provide you and ourselves with the tools to be the best versions of ourselves.
We are your hosts, Dr. Grant Cooper
and Dr. Zinovy Meyler. We just wrapped up a conversation with Leroy Hood. Lee answers questions like, what is the best way to prevent neurodegenerative diseases like Alzheimer's and also cognitive decline in general? He also goes into a very important question of what is the best way to use data-driven personalized medicine today, and also what it looks like tomorrow, months, and years from now.
Lee envisions a really exciting future for medicine where we'll be able to look at really small biomarkers and then be able to identify disease states before the disease actually manifests, and using AI, be able to intervene and stop the disease from ever causing actual problems in people. And there's no one better to talk about this than Leroy Hood. Lee is a world-renowned scientist. He's the recipient of the National Medal of Science. He co-founded the Institute for Systems Biology in 2000. He served as its first president from 2000 to 2017. He's a professor and chief strategy officer. He was the chair of biochemistry at Caltech for 10 years. He is truly a pioneer and innovator in the field. He was just a complete delight to talk to, full of practical information and a vision for what the future holds for all of us. We hope you really enjoy this episode, and we really appreciate you watching these episodes. We hope you'll take a moment. It'll really help us out if you could like the episode. If you haven't already subscribed to the channel, please consider doing so now. It would really help us out as we grow our community and grow together. And if you could share it with a friend, that would be great too. Please enjoy this episode. Lee, thank you so much for joining us for this conversation. You are one of the true pioneers and thought leaders in the world of personalized, data-driven medicine. And you've painted a future in medicine that has me and Zinovy really excited. It's a future where we will be able to look at someone's blood or maybe stool sample or other tissue, and we'll be able to see really small biomarkers that will give us that will tell us if there's a disease that's basically brewing. And then we'll be able to intervene at that stage long before there's any clinical manifestation of the disease where it can hurt the person. It's a really exciting future. How soon can we expect for that future to be realized?
I would guess that depends on the resources the government and others invest in it. My own feeling is within 5 years, we'll start to see many of the consequences of a data-driven health. And I would guess in 10 to 15 years, we'll see the real revolution coming in.
And does that mean basically in 5, because the way that I imagine it from reading your book and thinking about it, first we're going to need, you're in the beginning of collecting from 1 million people, lots of biomarkers, and we'll have to let that play out. And then we'll look back at the biomarkers and see, we'll look at when people got diseases, look a few years before that, and see what small biomarkers changed. And then we'll have an indication that those are predicting the disease. Does that sound right as the first step?
It is the way we have to go, but I will say this second genome project, a 1 million person project over a 10-year period, is something that's in the initial stages of persuading the government to fund, as it did the first genome project. And my guess is with the political polarization and with the two wars we're fighting, that's probably going to be a 5-year feature. So what we have in the meantime are a whole series of short-term objectives that go right after the same major initiatives the Million Person Project will carry out. And I can talk about those if you wish and how we're going to get started.
Please, yes.
So let me tell you, my view of health is that what we're proposing is radical health. And the reason I say that is medicine today is largely a failed entity for a number of reasons. One, the quality of health care in the top 20 nations has the US almost at the bottom of those 20 nations, in spite of the fact we spend 3 to 5 times as much as the next spender in healthcare. And this means that we're paying a lot of money and we're not getting a lot of quality. But the second aspect of the failing is the entire system lives off disease. The only place you really make money in medicine is if the patient's sick. They don't really care that much if they're well or if you can prevent it. I mean, the surgeons and the clinicians get their money when they have sick patients. And so the whole question is, how can we change this whole rubric of a disease-oriented healthcare to a wellness and prevention-oriented healthcare? And there the idea is this data-driven healthcare where we'll use genome analyses to uncode for each individual their source code that in the general way instructs you on how to develop. And we'll use the phenome measurements to assess how you change over time. And the phenome measurements are from the blood, they're from the gut microbiome, they're from digital health devices, they're from imaging and looking at your brain and looking at your body. All of these things get integrated together. And what this allows us to do is literally take billions of assessments of your wellness and focus on A, how to optimize it, or B, discover any small deviations toward disease. And hence the early stage is what's going to give us the preventive measures we can use to ensure you never get this illness.
Are we in the process of collecting that data now? I'm sorry. Are we in the process of getting that data now?
We are in the process of getting that data now. I mean, in a sense, we did a validation with this when I started a company called Aerofail about 8 years ago or so. In 2015, it existed for 4 years. We recruited 5,000 people, and we did this genome phenome analyses, and we discovered data-driven approaches gave us deep insights into actionable possibilities that could improve wellness, that gave us deep insights and the ability to measure how we're aging, which was actually a proxy for measuring how well you are. And these measurements actually gave us insights on how to optimize the aging process and so forth. They also gave us insights into your metabolism and how well it's going, into your immune system and how effective it is at different times. And those are all the things we can begin to use this data-driven approach to collect and assess from literally billions of data points your status of health, and then make recommendations about how to optimize that toward a wellness rubric.
How important is it to have a database of general information? And one can expect that as more and more people get into that aspect of healthcare, that grows exponentially. But at this point, is there any foresight as to where the tipping point lies, where there is enough data to actually act on from the general public?
Well, I'll tell you, from the Aerofail data with 5,000 people over 4 years, I think we have a validation of all the major points we take in viewing wellness and prevention. The idea of a database that increasingly collects information is really a critical point. And in fact, we've designed a special platform at a nonprofit I formed 3 years ago called Phenome Health to really push this whole vision of data-driven health. We have a platform now that gives us enormously effective abilities, to store large amounts of single types of data, protein data or metabolite data or lipid data, and to integrate the different kinds of data together. And in doing so, you reconstruct the nature of the human being by integrating the data that's surveying different aspects of their health and wellness. And this whole business of learning how to integrate the data effectively is what is really going to transform healthcare in the future, because with every integration type you do, you explode out the number of new actionable possibilities that for given individuals can lead to wellness and prevention of disease.
And it seems like as computing power continues to increase and as AI becomes more and more actionable, it seems like that would be helpful too, I would imagine, in terms of parsing all of that data.
I'll tell you, AI is going to be one of the big transformational events in healthcare. And what the physician and his partnership with AI, especially with these large language models, is going to be able to do in the future is to essentially give the physician access to all the domain expertise of the entire field of medicine. So you'll be able to treat every patient you have and the entire spectrum of diseases we know about and bring to them the very best treatments. And we're now in the process of working with a large language model that is actually learning how to assume genomic and phenomic information and make enormously deep predictions about individuals and how we can optimize their wellness. So I think AI is absolutely going to transform medicine in exactly the same ways that healthy water, that chlorination, that in some ways the DNA sequencer did. Those are all technologic advances that just transform the dimensions of what we think medicine is.
It seems like there's two broad ways that seem very exciting. Like one is to be able to intervene at the disease stage. There was someone from your previous company where they were able to look back. I think it was pancreatic cancer. Is that right? Where
Right.
looking back, you could find biomarkers that could have predicted it years before, and so as we can see all these biomarkers for different disease states, we'll be able to intervene. The other side of the coin seems to be if you can get at the actual process of aging itself as the underlying denominator that causes all of these disease states. Do you foresee a future where we can intervene at the, there's all these, David Sinclair and at Harvard with his anti-aging lab, longevity center. Do you foresee a future where we can use this data to help people slow the actual aging process on a molecular level?
I do unequivocally. So let me address both of those questions. In Airvale, what we discovered over that 4-year period we looked at these people is there were 167 individuals that transitioned from wellness to all the major kinds of chronic diseases. We looked at 10 people that transitioned to cancer, and for 10 out of 10, we were able to discover blood biomarkers that predicted the transition anywhere between 1 and 4 years prior to the clinical diagnosis. And with cancer, that opens up the really exciting possibility that we can use these new, very powerful immunotherapy techniques to go and clean out the cancer when it's simple, when relatively few cells have transitioned. And when it's absolutely susceptible to a focused preventive attack on it. And our hope is with the Million Person Project, where we predict there'll be 200,000 such transitions, is we'll know for every chronic disease exactly what the markers are that say you're going to get this in 2 years, 5 years, 3 years, whatever it is, and hence we better prevent it. And the reason that is so important from the economic point of view is 86% of our $4.1 trillion are spent on chronic diseases. And let's suppose that we can get in a 5-year period to a 10-year period rid of half the current chronic diseases. You're talking about trillions of dollars of saving, not the least to say you'll transform many people's lives. Of course, the downside of it for a disease-oriented healthcare system is, hey, you're taking my patients away from me. I'm not going to make money. And the whole rubric is going to have to be, you can make a lot of money in keeping people well and preventing disease. You just have to figure out how to do it. And I think the drivers for that are going to be the payers themselves, because they'll realize in a flash the enormous savings that can come from here. And so we're going to try and use them to push this kind of a view.
Have you seen any actual pushback to this revolution from either lobbyists or healthcare as a system?
I'll tell you, I've lobbied Congress on both sides of the fence, and both in the House and the Senate. And I'd say the people I've talked to in general have been really enthusiastic about it, and that's both R&D people. I think the people that are skeptical about a data-driven science now are the scientists themselves. And I'll tell you, it was exactly like that when we started pushing the first Human Genome Project in 1985. I would guess 80% of the biologists utterly opposed the Genome Project because it was big science and it was going to take money from small science, which it never did. And the NIH absolutely opposed the Human Genome Project right up until the end when it got funded, almost 1990. So I think scientists are terribly conservative people, and they're used to doing what they learned to do in their PhD theses or their MD theses and so forth. So you have to get by this revolution. Now, I think the second thing that we run into is the National Institutes of Health is funding a million-person project as a big research effort, but they're only doing genome analyses and some electronic health records and some digital health. They aren't doing the phenomic analyses, which are what capture how we change as we age and everything. And I'd say that was a major flaw that I've argued from day one with them that they should change. And their argument, which is not unfair, is that it's expensive. But my argument is it's the way it's going to be done in the future. Right. And look, if you go back to the Genome Project, the first genome cost $1 billion. Today's genomes cost under $1,000. That's 10 to the 7. That's 7 orders of magnitude decrease in cost. And the Human Phenome Initiative will do exactly the same. It will pioneer the development of technologies which will drive these costs down of phenomic measurements and make them far more effective.
Friends, we hope you're finding value in the content. If you're enjoying what you're watching, please consider hitting the like button, help us with our YouTube algorithm, consider subscribing to the channel, and turn on the notification button to stay up to date with everything going on in the channel.
So on aging, I'll give you my own particular biases. I think this is absolutely a fascinating field, because aging mechanisms are one of the most highly conserved mechanisms in all of organismic evolution. And what that means is you can begin to look at how a yeast, a single cell, ages, and you can make deductions that apply all the way up to human beings. So we can use yeast, and we can use the small worms, the nematodes, we can use flies, and we can use mice, and we can gain enormous insights into the aging process. And like as not, those apply very, very nicely to humans. But what has been failing in the aging process up until the last 10 years or so is a mechanism for measuring the aging process itself. And there are two general aging measurement processes that have been pioneered. One we did with the airfield data on the multiomics. And the second, Steve Horvath at UCLA pioneered using epigenetics. And he showed the changes that you see in epigenetics can indeed predict the rate at which you age. And we did exactly the same with metabolites in the blood. We could show by looking at proteins, or by looking at metabolites, or by looking at clinical chemistries. All three of them let us predict what we call the biological age. So that's
looking at telomeres. Is that part of that? Looking at the telomeres and the length
looking at telomeres is another part of it. It hasn't led us quickly to actionable possibilities. I mean, if you look at aging, there are now, I think, something like 12 hallmarks of aging, and telomere shortening is one of those. But what is interesting is there seem to be major mechanisms that operate to modify multiple of those different hallmarks of aging. So what you want to direct your modifications at are these major control mechanisms rather than the end stage of telomere change or
the marker. Yes.
And almost all the anti-aging things are focused on looking at the end stage hallmarks of aging. And maybe it works and maybe it doesn't, but certainly it's going to be much more powerful to use a drug like rapamycin, which seems to operate at this higher control level, to actually influence multiple aspects of aging in model systems. And we're just beginning to run clinical trials on humans. But getting back to the one point I'd like to make on aging, our metric for aging, for the first time, we could go back to the Airfield data, and we could ask for people that stayed in a program focused on wellness, what happened to their aging over that 4-year period of time. And the results were absolutely remarkable. For women, for every year they stayed in the program, they lost 1.5 years of their biological age. And the idea is the lower your biological age is from your chronologic age, the more effectively you're aging. And for men, it was about 0.8 years. And whether that was compliance or what, we really don't know. But it absolutely validated that this omic measurement of aging was really an indication of wellness. And the other thing we did is we looked at 40 different diseases that came up in the Airfield population and showed for 40 out of 40, the biological age was above their chronologic age. And when they got well, the biological age shifted back down to a lower level. And finally, we could actually look at major organs. So the kidney, the liver, the immune system, the metabolic system, and we could assign ages to that. And because of that, when we looked at the metabolite aging process or the clinical chemistry aging process, we could tell individual patients exactly what they had to do to optimize the decrease in their aging process. And I had one friend who actually lost 10 years over the 4-year airfail period in his aging process. So the question is, how far can we really drive that whole process down? And then the point you made is really key, because for all chronic diseases, the major number one factor associated with them is aging. Well, let's say that we can really diminish the aging process. Maybe in a global way, we prevent an awful lot of people from ever transitioning to a chronic disease. So whether we use scientific wellness to do this, or whether we use this aging metric and its ability to reduce aging, we're converging toward a really exciting point of view, and that is we want to extend your health span. That is, the time your brain and body are both healthy and agile and functioning, into the late 90s, the hundreds, and maybe in the future, even beyond. So that's a common shared vision that comes out of scientific wellness and healthy aging.
And right now, in terms of intervening with the aging process, what we're really talking about so far is just lifestyle, like simple things, lifestyle interventions and treating disease states, but mostly it's lifestyle interventions. Is that right? We're not talking about metformin or rapamycin or any of these more newer experimental things.
Well, I think we are, in the sense that we have to do the experimental
Well, I just mean that
trials
in
to
the
validate them. But
right.
what has been validated is exercise,
Yes, that's what I
is
meant.
diet, is the proper amount of sleep. These are all the kind of common things that ordinary health companies push you for. What the data-driven science do is they allow you as an individual to optimize all of those aspects of wellness, of health, in ways that you couldn't do as an average process in a population.
When you look to the future and you imagine, or you can see us being able to look at the biomarkers or look at the aging, do you foresee a future where you would then be able to tailor a very specific, personalized medicine or supplement for that person? Or is it more they'll fit into a box of, this disease state that we can see early on, and then we'll do this intervention that would be appropriate for millions and millions of people?
I think the answer is both, because I think there'll be some general interventions that'll really be effective for an awful lot of people. We should use them. But I think there'll be individual variations that give you unique opportunities for optimizing the ability not to transition into cancer or cardiovascular disease or whatever it is.
Yeah.
So in a sense, it's the decision process for this is like a tree, and there'll be some big things down near the trunk where a lot of people will be helped by it, but there'll be a lot of things out here at the end twigs where we can do things for just 1 or 2 or 3 people out of 10,000. And we ought to be able to deliver the unique medicine as well as the shared medicines, because we, in the end, want to be able to assess the health trajectory of each individual and optimize it based on the billions of data points we collect that assess every aspect of your health. And there are 3 major aspects of health we can talk about: brain health, which is almost totally ignored today; body health, which is what most people talk about; and then the gut microbiome health. It's the window through which everything you eat is viewed and modified. For example, we've shown that the gut microbiome has profound impact on how statins are used, both in terms of clinically what you'd like to do, lower LDL cholesterol, and or in terms of major secondary effects like pushing you toward type 2 diabetes. And we think we'll be able to design gut microbiome that can optimize those 2 features of a drug. That is, make the good things better and make the worst things very low.
And do you think we'll be able to modify it that quickly? So if somebody sends in their biomarkers and you say, okay, we want to individualize it for this person, will we be able to turn it around using maybe AI? And then I'm trying to imagine how that works. Like it goes, you would need to be able to customize something relatively quickly.
Well, I think we're at the very beginning of understanding how to manipulate the gut microbiome, for example.
Yes.
But I mean, in the last 2 or 3 years, we've learned so much about it and so much about how to manipulate it. I mean, one of the really interesting studies that we've done more recently than Airvale is to look at about 6,000 people that were, 9,000 people that were 60 or older. And we were able to show the gut microbiome had a profound effect on whether you aged healthy or not. And there were 2 features of the microbiome that changed in terms of healthy aging. One was you lost many of your common microbes, gut microbes you had back in the 20s and 30s. But the second was the healthy people differentiated to unique individual gut microbiomes that were different for each one, almost as if the microbiome had figured out how to help the individual optimize and deal with the changes that aging brought. And in contrast, we found people that were unhealthy in their 70s and 80s didn't lose all the early gut microbiome features, and they didn't individually differentiate. So here's a very clear classic example of if we could facilitate the good behavior, that's another approach we could take to facilitating good aging.
That's great.
Very, very interesting. One thing to just sidestep a little bit, when you mentioned resistance to change, that's sort of a predictable surprise, if you will, because just historically, healthcare has not been very, very likely to change from hand washing to, historically, hand washing was laughed away until 30, 40, 50 years. The microbes were discovered, and then now we know to wash our hands.
Well, look, anesthetics took a long time to become acceptable too. Yeah.
Yeah.
One of the things we were discussing as just from our perspectives, from our practice, one of the P's, the participatory P's in the overall individualized process is the participation, right? The buy-in of the individual in order to be healthy. And from our experience, we deal with a lot of spine problems, and when someone comes in with tremendous amount of pain, and we treat them for radiculopathy, a sciatica, a pinched nerve, and once they are better, we discuss with them the ways to make it better and also prevent it. Proper posture, exercise regimen, and so on. The whole multimodal approach to managing, preventing pain. What we find is adherence to that is tremendously small, and people just don't, even though they've just experienced tremendous pain, they just don't follow advice, and they don't.
Or they do they'll follow an exercise regimen for a few months, maybe.
Maybe, yes.
But if it's too involved, they tend to fall off.
Absolutely. Yeah.
Yeah. And so how do you foresee that barrier? Because it seems to be, for us, it just seems that this was so clear that you need to do this, and they don't. And we're talking about preventive.
Even on a personal thing, when I see calories on a menu, it irritates me. I'm like, I don't want to think about it. I just want to.
I want to eat that
tell me how bad it is.
Yeah.
Don't tell me what's in the donut.
So I'll tell you how I've approached it. Again, in early 2000s, I proposed that healthcare should be 4P, and it should be predictive, preventive, personalized, and participatory. And what I would argue is the first 3 Ps, prediction, prevention, personalized, are really science. And there we just have to figure out how to do things. And we're really doing that very well. I would say the biggest stumbling block in medicine today is the 4th P, participatory.
Yeah.
And the essence is what you said only it extends way beyond. So how do we persuade patients to participate? How do we persuade physicians to participate? How do we persuade your healthcare leaders or your healthcare technology leaders or your regulators or your politicians? And it goes
Sure.
on and on. And,
Right.
we have two classes of people that we have to deal with. And one class I think is pliable and really where we should focus. That is people that are in K through 12 education processes. Because I would argue, how do you persuade people who are adults to look beyond football and basketball and all of these great streaming shows and everything and think seriously about health and so forth?
Yes.
So a couple of things we're doing now is one, I've written this book, The Art of Scientific Wellness, and hopefully wrote it in a way that the lay public should enjoy, but I'll acknowledge that it's going to be a small fraction of a lay public that reads a book like that. And two, we're in the process of working with a person that was former CEO of Universal Studios, who's made hundreds of films. And we're trying to design a film now that talks about 5,000 years of wellness and ends up with the lesson that the most revolutionary transformation in health in 5,000 years is the data-driven approach that lead us to wellness and prevention as opposed to disease. And
Wow.
and
Right.
it's actually really been fun to talk about that. But, you have to raise money, you have to get a good script writer, and we're doing all of that, and we'll see where it goes. But
I
in
feel
the
like
more productive area, which is in K through 12, what we did when I started ISB in 2000, I had an education group set up that's been enormously successful that really focused mostly on K through 12 education. And what they've done over the last 3 years is take a textbook that we just finished on systems biology and systems medicine. And they took the two chapters on systems medicine and P4 healthcare, and they've designed a junior senior course, a year long, 4 modules that has all the things we're talking about here. And I'll argue that the kids that come out of that course will know more than 95% of the physicians out there, not only about the future of wellness, but they'll have thought about their own future of wellness in such a way that I think it hopefully will program automatic responses to being susceptible to the logic of the kind of things you were talking about in prevention after you've brought patients through a difficult and trying therapy and everything. So I think education, and it has to be done from the point of view of psychological and sociological. I mean, another really interesting question is, look, if you live to be 100 and you're mentally alert and physically capable right up to the end, a really interesting sociological question is, what are you going to do with the extra 20 years? And I'd argue that playing golf and tennis gets a little boring. I'd argue it isn't sufficient.
Yeah.
It's great for the exercise, but it's not sufficient for the mind. And and our kids have to have instilled this idea learning is lifelong. And I think the noblest thing anybody can do is have a commitment to bringing to society the fruits of their labor where relevant, whenever you can. I remember, for example, in 1979, arguing with the president of Caltech, a physicist at that time. I said, look, I'm developing 4 instruments. They're going to have an enormous impact on the biological community. I want to go out and find a company that will help me manufacture these instruments. And the president gave me this long diatribe about the purpose of educational institutions is education and scholarship. It isn't commercialization. And I said, I couldn't disagree with you more. I think every scientist, in our ways are paid by society, has an obligation to bring to society things they think are going to benefit society. And that's why I've always believed in starting companies and spinning off opportunities and things like that. But I mean, how you persuade, and you know what persuaded the president is we started a number of companies. He saw the amount of money they brought in after, and all of a sudden Caltech became one of the hot techies. And yes, let's start as many companies as we can, and we want a piece of the companies. So it's in the end, I think the really important component of data-driven health is going to be convincing healthcare systems that they should integrate the payer and provider functions, because the cost savings from data-driven health are going to go to the payers initially. And if you've integrated them, they'll both experience the benefits. And that's exactly what I'm looking for now is integrated payer providers to bring this new data-driven health. And we are in the process of negotiating with one ideal candidate in this regard. And if we succeed, they're going to be a model for the future of medicine. There's no question.
That's exciting. Yeah. Something, as to bring it back just a moment for something you said a couple of moments ago, I couldn't help thinking as you're talking about the importance of, sort of like a purpose-driven life, right? And a few weeks ago or so, I forget exactly when, but we talked with Vernon Smith, he won the Nobel Prize in economics in 2002. He's 97, and he's still sharp as a tack, still going around lecturing and writing. And when you talk, and it's like him and you just reinforced to us, I think, how when you have a purpose, that it really keeps you going, and it everything functions better. Something that I wonder so much is if you could look at those biomarkers of people who are going through life, and if they find themselves dropping off without a purpose or retiring and then going to play golf, 18 holes every day, I wonder if the biomarkers change as people, sort of go through either traumatic issues in their life. It would be interesting to look at those biomarkers and see how that.
Well, I'll tell you, we're collaborating with a company called Posit, which has electronic assessments of a whole series of different cognitive features, about 20 different cognitive features. So reaction time, depth of field, memory, those are all cognitive features. And they can actually monitor all of these different cognitive features and say you're deficient, and then they can give you exercises that reconstitute them. And Michael Merzenich won the Kevley Prize for demonstrating the brain is flexible. And one of the things he did is he took a bunch of 80-year-olds and reconstituted them back to where their cognitive optimum. And for most people, you rise to an optimum in your mid-30s and you gradually fade away. He showed you could bring most of those people back up to where they might have been in their mid-30s. So what's really great is there are ways that we can visualize keeping our mind as effective as it is right now, too. Not only that we can talk to one another, but that we can be creative and energetic and driven and
what's the name of that? What's the name of the company?
It's called Posit. And the exercises are called Brain HQ and
yes, that's right.
That's in the book. Yes,
we've talked about that, and it's really exciting. And do you think this is a possibility when looking at certain personal devices like the Oura Ring or an iWatch or Fitbit? It's very interesting to watch some changes that you can make in your lifestyle, like drinking coffee a little earlier in the day, or having an alcoholic drink sparsely or not at all closer to going to bed, how it affects your sleep stages and so on and so forth. And if biomarkers were available where you start seeing that you're starting to age more and you can course correct, a 1 degree course correction at that time can make such a tremendous difference.
Well,
And you
I'll
get
tell you,
agents.
biological age is a global measurement. You can course correct. My argument is we all should have our biological age done on a yearly basis. And we should follow the slope of, I mean, the ideal slope would be going down slightly, right?
Yeah.
Almost for everyone, the slope is more or less parallel to what your age is. And the only question is how far below your chronologic age slope you are.
And it may be, by the way, that just having that feedback of once a year, checking that might be how you get that participation
Yeah.
from people as
Well,
well.
I wear an Aura ring, and I'll tell you, it's changed my sleep habits in really quite remarkable ways. And
Absolutely.
it's, you get up every morning and you say, okay, I got a 94 today. That's the best I've ever done. Or, okay, I got a 56.
Yeah.
Wow, what
Yeah.
happened? And I'll tell you, it is really correlated with drinking, how well you sleep, for me.
Yeah.
And, that's the individual thing about it. We can't write general rules for
Right.
people because we're all different. And we have to use this information and optimize us each individually according to the opportunities we have. And that's what taking billions of measurements does for you. It reflects health and it allows you to make, and right now it allows physicians for the most part to make decisions that lead to actionable possibilities that if you follow them really benefit you.
Are there general recommendations that you have from? I mean, we just finished saying that everyone's so individualized, but you've been following these biomarkers for a while with different groups of people. Is there anything that stands out where you would say, beyond, I think we all can understand diet is important, fruits, vegetables, fish, exercise. Are there other recommendations that we can start making for people?
Like common patterns.
Common patterns that you've noticed, or medications like metformin or
Yeah, and
rapamycin?
they can often be quite complex patterns, so they're difficult to describe. But look,
Hmm.
a common one that we all accept now is LDL cholesterol,
Yeah.
that being low and HDL being high. And I'll tell you, different things really perturb those for different people. One of the interesting things we demonstrated in Airvale, which is really exciting, is we took the 5,000 Airvale people and we looked at the polygenic scores for LDL cholesterol, and we converted them into a genetic risk, low for LDL cholesterol increase or high. And what we were able to show beautifully is if you were at high risk for LDL cholesterol and you had high cholesterol, the only thing that brought it down effectively were statins, okay? If you were at low risk and had high LDL cholesterol, you brought it down beautifully with diet and exercise. You didn't need chemistry. And what I'm going to argue is we now have almost 200 polygenic scores that can be converted into genetic risk. And we want to do that for the physicians because you're going to treat high-risk people differently than you treat low-risk people. And the other point we've discovered is we correlated then high-risk and low-risk people with thousands of analytes from the blood, and we were able to show the very high-risk people had analyte profiles that looked exactly like those that had transitioned to the disease. For example, type 2 diabetes had a profile that was virtually indistinguishable from that for diagnosed diabetes. And the important point is those that are upper 10% or so of genetic risk should start thinking about preventive measures for major chronic diseases.
Yeah.
And the only question is, is when you do that. And I remember the experiment. One of my close friends, he came from a family where virtually all the men had died of heart attacks by the time they were 50. And what he showed beautifully is his LDL cholesterol was rock bottom until he hit 35, and boom, it went up to 300 or something like that within the course of a year. And he brought it down with cholesterol. But knowing that that was going to happen and doing it preventively is the thing we want to be able to do.
In collecting data, just to bring us back also to the first three P's of the scientific three P's, in the collection of data. So just to take it back for a second, in your book you described that in 1948, our understanding of genetic material was proteins and not nucleotides as we see it now, and that discovery was really pivotal to our understanding and ability to collect data and genome project, etc. Have you noticed any findings that are similar to that in your collection of data? Has there been a pivotal finding? And conversely, do you foresee that there may be a pivotal finding that will change our understanding or approach to our biological age or prevention of disease?
Well, I'll tell you the types of strategies that I think are going to give us exactly the kind of insights you've talked about are those in which we can integrate different data types together and come to conclusion about the coordinate impact they have on your health, or even put 3 or 4 or 5 different data types together and see what they're doing. And we're doing this in a lot of different ways. And I think it isn't often going to be that a single analyte is a measure, but it's 5 analytes that do these things together. And that's why we're using AI to start deconvoluting the complexity of the phenomic patterns that exist in individuals so that we can begin to relate that to the actionable possibilities we need to do to remedy defective situations. So I think it's going to be AI and the integration of multiple types of data that give us deep insights into, look, you're on a and the kind of insights they give you are essentially estimates of your health trajectory for a given set of conditions. Okay, and for example, we've been collaborating with colleagues that have developed a wonderful digital twin for brain health now. And what you can put into that is really beautiful. And a digital twin, what you do is you collect all the physiologic data and the mechanistic data in a top-down entry, and you collect the clinical markers and the omic markers and a bottom-up kind of thing. And it does kind of an integration of information. But what we were able to do, for example, is take one of the first of these anti-Alzheimer's drugs and put it into a series of digital twins and ask how much did their health high-risk digital twins, and ask how much did their health trajectory for transitioning to Alzheimer's disease change. And the answer for the first of these drugs was by 1 month. Then we took the exercise strategy that been employed by a clinical trial in Finland called FINGER, and we put that into the digital twin, and that gave you 6 years of extra life before you transition. So the drug did nothing virtually, and exercise did an enormous amount. So
the
those are
potential
the kind of things we're going to be able to predict in the future.
What is the digital twins extrapolation based on? So when the program extrapolates for one digital twin, the intervention, is that based on the currently available studies for that particular intervention?
It's based on putting in all of the data that you have across different aged people and looking at how their profiles change. Okay. I mean, that's a simple way of looking at it.
Yeah.
And these studies, for the most part, haven't been done with phenomics, but they've been done with people whose brains have autopsied after they died at different stages. So it's a different set of measurements, but it gave us the ability to make predictions that seem to make sense anyway. The omic data, we're actually raising $50 million with the Buck Institute and other collaborators now to set up a high-risk Alzheimer's trial that will give us the phenomic data we need to do this really powerfully. So anyway, the key for all these predictions and the accuracy of the digital twin predictions is longitudinal data and lots of it. Those are the simple imperatives.
Yeah, makes sense.
Very exciting to get those million people. It just seems like that'll just blow it up with so many data points.
Well, and it'll answer so many questions,
Yeah.
and it'll give us unequivocal financial data over a period of 10 years to show how these million people, A, increase in quality of healthcare, but B, save the healthcare system enormous amounts of money.
Yeah. You worked with Bill Gates before. Can we get him on the phone and get him funding?
Well, that's one of the places we'll be going. He's very interested in Alzheimer's now because of his father, who recently died from Alzheimer's.
Oh, I'm sorry, I wasn't aware. Yeah. Yeah, I mean, well, it affects so many people, right? It's such an unfortunately common problem as the population gets older.
Yeah.
Concerns about? Yeah.
Yep.
One of the things that can't help but come up when we think about big data and personalized medicine and all of these huge data sets and our own data going out into that cloud is the idea of how concerned, in the James Bond movies, what was it? There's a hypothetical poison.
Yes, in the latest
You
one,
wanna
there was
do
a
it?
hypothetical poison that was genetically modified to target specific people and be harmless to others. And of course, it's a hypothetical and a hyperbole, but the idea of at some point, are we looking at starting to protect our excrements that where people can get some genetic information from, like we would protect our Social Security now today? Is that something you foresee being a reality?
I think it is utterly critical to this whole vision of data-driven health that you be able to assure the patients that you can de-identify their data and separate it from their identity, and then before you carry out these analyses.
That's for the
And
studies. But what about when
and I'll tell you, we actually and the other question, of course, is the question of security. Are you confident that you so what we've done in the collaborations we're setting up is we always have a clinical honest broker who has the key for the phenome and genome and the individual's identity. And that's absolutely isolated from anything we have. And it's virtually impossible to get to under any reasonable kind of circumstances. So I think we can assure that you can keep things de-identified and so forth. Now, the whole business of using genome engineering to, avoid
weapon?
as we have now, Mendelian recessive diseases, that's really terrific. But we'll be able to go on and do much more sophisticated things. There, I think it's going to be a matter of regulation and social coercion about how we manage those kind of things. I don't see those in what we're talking about now as being a problem, because if you want to target certain individuals, look, all you have to do is go and get the can of Coke that they drank from, and you have your DNA
Right.
associated with that individual. I mean, you're not going to go to some big data system where we've got things
To
all
that
hidden away.
to that point though, if you had someone's like in the same way that the promise of this extraordinary, hopefully near future, is that you could take someone's biomarkers and engineer a treatment for them that's specialized to them. You know, could you use that for nefarious purposes too? You could get that Coke bottle, see the
Well,
biomarkers, or no?
yeah, absolutely. I mean, that seems to be playing out, at least the anxiety of that seems to be playing out in the political arena when President Biden, I believe, with Putin were supposed to meet, and Russia didn't want to allow him to come in. They said, we'll do a COVID test. And Secret Service refused because that was a way to get the biomarkers and to get the DNA.
Mhm.
And
Oh,
conversely,
is that right? I mean,
Yeah,
I
correct.
think that's
I didn't know
I
that.
think
that
that's
was the
really
whole,
interesting.
if you
Yeah.
remember that long table, that was the compromise, is that, oh, if you're not going to give us the COVID test, then we're going to compromise and we'll have this ridiculously long table and we're not going to have a personal conversation. Conversely, Putin allegedly has a team of people collecting any biological excrement or anything that comes out of his body, collecting it and incinerating it for the same purpose that no one is able to collect it. So anxiety certainly is there.
Well, and at the same time, in the same way that before sequencing a genome was, you know, astronomically expensive, but now it's not.
Right.
Right now, maybe only heads of state have to worry about, you know,
Right.
these kinds of things. But you can imagine a day when, if you know, you could phenotype a family, you know, and design something that
Yes.
targets that family or that group. I mean, I guess there's just there's no way to completely prevent that.
Right.
It's just maybe.
You know, I don't think, and look, I think the techniques of data-driven health and where we're going are plus or minuses in that regard. You can go get these things easily from local utensils and things like that they use. So, I mean,
And then use the same
now,
kinds of.
it is a really interesting question of how we can prevent the emergence of those kind of strategies. And, you know, those are tough questions. No question.
How does personalized medicine deal with infectious agents? How does that work?
I think it's pretty straightforward. For example, during COVID with Jim Heath at ISB, we took about 300 individuals when they first came into the hospital, okay, and we drew blood. At that time, we drew blood at 10 days and we drew blood at 3 months. So it gave us the beginning diagnosis. It gave us the 10 days of acute infection, and then it gave us what's happened afterwards. And we did deep omic analyses. And in addition, at each of those 3 blood draws, what we did was to look at 5,000 white blood cells with single cell analysis, cell surface analyses, secreted analyses, and we were able to define what each cell type was and its stage of differentiation. And we followed by integrating these 5,000 cells, the interacting adaptive and adaptive and infectious immunities, the 2 immune systems, B and T cells and innate immune systems. And it was enormously revelatory in the phenotype and nature of the infection, and it gave deep insights into long COVID and what's likely to be happening there. So these powerful tools essentially let you do precision medicine at a level that's never been done before.
But so it would be more about enhancing one's own immune system as opposed to analyzing the viruses necessarily. You know what I mean? You see what as opposed
Well,
to.
we looked at the virus too, and we looked at the cells in the virus, T cells in the virus, to see what you can do you can do everything.
You can do it
You
all.
can look at it from the host point of view or from the vector point of view.
Right. And then you can look at the vulnerabilities in the vector with the same
Yeah.
analyses. Yeah. Okay.
And in those studies, one of the really interesting things we came up with is that day one, when you enter the hospital, there are 4 different predictors for whether you're going to get long COVID or not. One is diabetes. It predisposes enormously to it. The second is the activation of oncoviruses. The third is the presence of autoimmune antibodies of various types and so forth. And the fourth is if you come in with a lot of infectious RNA, you're much more likely to get long COVID than if you don't. So, and we had a Cell paper on that got enormous distribution across the media and so forth. So the precision medicine that's possible with genome-phenome analyses of individuals are very powerful tools for looking at diseases. But we're using them to look for wellness and prevention.
Yes. Yeah. I'm just curious, when it came to that paper, were there any clues as to what one might do to prevent long COVID?
Well, the fact that certain kinds of autoimmune responses and viral infections, there are things you can think about doing to prevent those kinds of things.
I suppose you think about steroids maybe, or
No, it does open you up to new strategies for dealing with long COVID.
It's very exciting. I want to get Gates and Musk and get them funding this the larger study, because it's a very exciting future to think about. Speaking as two doctors who would, I think we'd be happy to look for other work if all of our patients didn't need us, then we could find a way to fit into that new
I think
future.
you're going to be okay for some time on patients needing you. We may reduce disease. I don't think we're going to eliminate it for a while, but
and this will presumably be layered in as time goes on.
It'll be layered in as time goes on. That's exactly right. Yeah.
There was a study, not a study, I guess, but they were looking at the game Go. I can't remember what book I read this in. I read it recently. It might have been, if it was your book, I'm sorry, just tell me. But they were looking at the game Go, and they had the best Go player play a computer, and that Go player got beaten pretty easily by the computer. And what they found, though, was that the best combination was a person,
we did talk about that in the AI chapter. Exactly.
Okay, yeah, playing with the computer, right, as an asset, as a team.
So it said the human was creative, and the computer could do a gazillion calculations on estimations, and the two together were unbeatable.
Right. Yep. And that really spoke to me with medicine.
See, that's the partnership that I envision with physicians and AI.
Yes, I think clearly.
Together they'll be unbeatable.
Yes. Yeah. I think that's, at least in the midterm, it seems like that's where we're headed, which is very exciting.
Yeah, absolutely.
You got anything else?
Yes. Well, there was so much about the neurodegenerative disorders that you touched on. One of the really interesting concepts was the perfusion theory, as the neurodegenerative disorders are more prevalent when the perfusion is a major factor. And then the Alzheimer's and the target of the Alzheimer's treatment was always really just a marker, not necessarily the problem in itself. And so I guess that is one of the pivotal findings, right? When you're finding that what you've been fighting is actually not the cause, but rather a feature, if you will, of the disease. Do you find that in someone who has already developed some neurodegenerative features, is there a reversal? Is that likely? Is that possible?
Well, I would say, so the idea here is that for 15 years now, many people, including pharma, has believed amyloid was a key amyloid or tau. These are two proteins that form aggregates and precipitates and things. And the ideal has been to find drugs that could dissolve the amyloid away or the tau away, and things like that. And slowly but surely, pharma has succeeded, but to a first approximation, it hasn't made very much difference. And, you know, it's it's a general form of what I think happens with most chronic diseases like cancer. What happens when you come in with a full-blown cancer is you have many different biological networks that have been disease perturbed that are doing very different things. And you can make a beautiful drug that manipulates one network, but it doesn't touch all the rest. So, in a sense, what you're doing is you're creating really expensive drugs for symptoms, and maybe they'll have some temporary effect on the cancer, but almost all of these fancy drugs, which are supposed to be the grand synthesis of success in medicine, they just lead to temporary relief, and pretty soon you're resistant to that drug and you go on to the next $10,000 a year drug. I remember reading in the New York Times a woman with breast cancer that had gone through 8 or 10 such treatments over a period of 7 years, something like that. What a miserable way to live. And she was probably in clinical trials, so I would guess she didn't have to pay for it. But if the patient had to pay for it, your family would end up being destitute at the end of that time. So, and that's the most compelling argument for learning about disease at the early stage and preventing it when you can do something about it. And I put Alzheimer's right square in that profile. And the clinical trial we're doing on Alzheimer's is going to take a large number of very high-risk individuals that haven't transitioned yet. And over a 4 or 5 year period, we're going to follow them to see the transitions and the early stages and come to learn how we can, through multimodal therapy, deal effectively to knock out all of the disease perturbations that have happened.
For that study, are you intervening in any way, or you're just following them?
The study will have interventions as well. Yeah.
Well, are those going to be more diet, exercise?
Yeah, they're going to be
oral health?
multimodal in nature. That's correct.
We've
We've already done a very small multimodal nature. And what was cool is we did it with a physician who was an expert in Alzheimer's and came in infinitely skeptical. So the control group was how he treated his patients, and the experimental group is a multimodal therapy we did. And the difference was utterly striking. And he's actually a convert now. He realizes that it's going to be multimodal therapy, but the trial was a very small one that just got published. And we're going to do a much, much bigger one. It'll have the convincing statistics that should satisfy the skeptical epidemiologists and statisticians.
And the people at high risk, are those people with ApoE? Is that like with genetic markers that...
Well, we'll define high risk in 3 ways, okay? One is a family history of frequent, you don't even need genetics to say that's high risk. The second is heterozygous or homozygous for ApoE4. And the third is there's polygenic score that actually in families segregates utterly independently from ApoE4. So whatever ApoE4 does to lead to Alzheimer's is different from what this collection of genes leads to. So what that says right off the bat is there are different subtypes of Alzheimer's, and we better get diagnostic markers that will let us determine the different subtypes and come to understand how we have, and we'll almost certainly have to deal with them differently.
Just to something as a takeaway of a more immediate action. Brain HQ is a beautiful program. As a concept, have you found that there is a particular activity that gets people more more neurodegenerative protection, such as Brain HQ, because some things like crossword puzzles perhaps make you better at crossword puzzles, and they're more task specific rather than improving your cognitive protection. Are there
Right.
some things that are better for that than others besides Brain HQ, which is a beautiful program in itself?
I'll tell you, I think Brain HQ is the best that we know of because it is an exercise and it challenges you. And let me give you an example of what I mean. One of the games they play is a flock of birds are sitting on the ground. And all of a sudden, they explode out in all directions. And there's one bird that is different from all the rest. And the game, what you have to do is tap which sector that bird is in. And what happens is the number of birds increase, the diversity of birds increase, and the timing of the flock explosion increases. And that really pushes you to the wire in a way Sudoku and crossword puzzles and things like that don't. I will say that Merzenish has done of the order of 250 clinical trials on all sorts of things. And for example, one of the really interesting things he did is he took people in the 75 to 85-year-old category, and they have an enormous number of accidents. And for example, they do for two very obvious reasons. One, their reaction time is much slower than it used to be. And two, their depth of field is gone. So they don't see anything from the periphery coming in at them. So he had, I can't remember, maybe it was 1,000 of each or 500 of each. A control group who did nothing, and the experimental group who played Brain HQ, and the results were unbelievably striking. I mean, it was a factor of, I can't remember now, 5 to 10 difference in the number of accidents experienced over a period of 2 years, whatever he did it.
It's incredible.
Okay. So that's the kind of, and the other thing he did with Brain HQ is he took people that really had difficulty reading, and he again showed them that this brain training broke them free of whatever constraints they have. And the control group, and again, the experimental group, the difference was just enormous in how quickly and how effectively the kids learned to read.
Are these different?
There are many, many different exercises that exercise different cognitive features. Yeah.
I see. Yeah.
And aside from that, would you think that there are other activities that increase complexity or spatial awareness that would provide cognitive benefits? I know dance has been cited as something that is advised because there's spatial awareness, there's movement, balance.
Learning an instrument.
Yeah.
Learning a new language. Are those kinds of things?
Yeah. Learning a new language is terrific. Merzenish says anything that forces you to do something routine in a different way than you've done it before is really good for you. So he thinks people going out and walking on sidewalks is utterly trivial. He said, go out on paths that are rough and you're up and down and all around. I mean, and it makes a lot of sense, I have to say, to exercise balance, to exercise adjustments to different foot placements and all of those different. Yeah, he says diversity is the key to retaining cognitive function.
Some degree of novelty, I would imagine, too. Something that you're not supposed
diversity,
to.
novelty, right?
Yeah.
Those kind of things.
Sort of like training a muscle. You don't want to do the same exercise every time when the muscle gets used to it, and then you don't get much out of it.
And that's why he says cross training is really critical. He said in your exercise, don't get into a routine where every day you go do the same thing. He said mix it up in all sorts of ways.
Yeah, mix it up and do Brain HQ and learn a language.
Yes, while dancing.
While dancing.
Is there any topic that that we didn't touch on in this scope that we should have, that you think we should expose people to?
Boy, I think you've done a good job in reaching in and pulling out most of the essences. I think the thing to really stress is how important that fourth P is, participatory, and the question that each of the viewers can ask themselves is, if I know it's good for me, can I force myself to do it? And I guess, I mean, one of the things that's amused me is this explosion of the anti-fat diets and things like that, with physicians who don't understand there are enormous consequences for some in using these drugs. And for example, I had a friend of mine lose 70% of his pancreas because it induced an acute pancreatitis that went on for months before it got so bad. My friend went to yet another doctor and he said, "Oh my God." And they went in and had to surgically clean up the mess in there. So,
Yeah, I think there's a lot of stuff coming down the pike on those drugs.
that's,
It's kind of scary.
and I mean, the other effect on those drugs for older folks is they're about as effective at dissolving muscle as they are at dissolving fat.
Absolutely.
And I'll tell you, sarcopenia in old people is what leads to falling and breaking hips, and
Yeah.
that often is the end for really older people. So,
Yeah. Yeah.
so these drugs, that's just as, I'm not saying they don't have uses, but I'm
Yeah.
saying, boy, be careful, because
Yeah.
humans are different and they don't all respond the same way.
To think about the participatory just as a slightly, you said, can you force yourself? And we've been talking to a bunch of psychologists about different ways that people can, motivate themselves and make better choices. And there's so many tools, I feel like, that have been validated, have studies behind them about how to get people to, do the kinds of things they want to do, develop better habits. I feel like, the time is now, hopefully, to start marrying some of these, the things that have been explored in like psychological fields with the interventions that we know work in medical fields, like diet and exercise and those kinds of things.
As another mode in that multimodal approach.
Yes.
Well,
Yeah.
I'll tell you, in Airvale, what we did is we had coaches that learned
Right.
all about the actionable possibilities that emerged from the data.
Mhm.
Yeah.
And a single coach could handle easily 200 to 500 people.
Mhm.
And the coaches were incredibly effective at, we had a lot of people that went all the way through the entire 4-year period. And most people, I think, were really responsive.
Yeah.
So I'm actually, I have talked in the last 2 months with 2 deans of nursing schools about the possibility that there should be an entirely new approach to nursing, which is training people to handle this data thing and the actionable possibilities and bringing it in compelling ways to patients. And all of our coaches in Airvale underwent psychologic training on how to persuade people, and different people find different ways they're effective, but they were remarkably so. And I think that could be a very effective approach. And one of the intriguing possibilities, and I almost guarantee you it's going to be true, I think in a 10-year period, we'll have avatars which will sit at home with each family and will analyze the data. And the family will be doing all the data gathering at home. You won't have to go to a hospital. It'll go in and it'll be actionized and sent to the physician and sent back to the patient. And then the avatar will facilitate making people responsibly active.
Speaking of scalability, that's
Right. That's the
See,
that's like
that's
a
the
holy
key.
grail.
Because
Yeah.
coaches don't scale. If you've got a 500 to 1 and you have 340 million people in the US, that's
Yeah.
a hell of a lot of coaches.
But at the same time, economically, it's a no-brainer for the insurance company, the whole system. But to me, a really exciting part of that would be the idea of being able to take your blood at home and not have to go to a lab. Do you think that's around the corner?
Absolutely. In fact, right now, Thorne, a company, has made a tool called Quick Draw, which you just put up against your arm and it does a little punch and it brings out 200 lambda of blood and it seals it in a tube that you can mail off then. So
It's
it's
enough,
very easy for,
it's enough blood to make real analysis from.
oh yeah. Yeah, I mean, for example, these, we have profiles that can look at 5,500 proteins and you need 5 lambda to do that. That's all.
Did you say Thorne, the supplement company Thorne? Is that who's doing that?
Who is that?
Is the company Thorne the supplement
It's
company?
Thorne is, yeah, and their
Wow.
major business is supplements.
Yes, yeah, they're
And
they're
they
very
were
good.
starting to get into healthcare. They've been acquired by a venture a firm, and I don't know
Okay.
what's going to happen now.
Okay, yeah, they're very well respected in the supplement making
Yeah, yeah,
industry. Yeah.
absolutely. Yeah.
Wow, that's exciting.
Yeah.
So anyway, I think we've covered probably enough for your audience to
Yeah.
think
you've been
about.
very
You've
generous.
been really generous with your time. Thank you so much for taking the time to talk about all of this. And it's a really, I mean, thank you even more for your pioneering of all this work because I really agree that this is where medicine is headed, and we wouldn't be nearly as far along if you hadn't pushed us there. So we really appreciate you for that as well.
Well, I'm not done pushing. I
Yeah,
can tell
no,
you.
keep going, keep
Yeah,
pushing.
absolutely.
Friends, thank you for your attention. We hope you've enjoyed the conversation. If you find value, please remember to hit the like button to help us with our YouTube algorithm. Consider subscribing to the channel and turn on the notifications so you can stay up to date with everything going on with the channel. And please leave us a comment, let us know what you thought about the show and also what you'd like to hear about in the future.